Welcome, this is Jesse Rogers, and today we are factoring. So what does it mean to factor a quadratic expression? First of all, that means that there is a 2 as the exponent of the variable. That's what makes it a quadratic, is that the leading highest degree of the variable is a 2. So this is a quadratic expression. This is actually a trinomial because it has 1, 2, 3 terms. And a lot of what you're going to be factoring are trinomials. So we'll get used to that. The first thing that we want to do is factor out any common factors. So first we can see that the 6, the 32, and the 10 are all even, which means that they're divisible by 2. So we're going to go ahead and factor that out. So what are the factors of 6? It's 2 times, and we said they're all divisible by 2. So let me do that while I have the red pen. All right, so now this is going to be 2 times 3y squared plus 2 times 16y plus 2 times 5. So what we're going to do is, because they all have that 2 in common, we are going to be able to take that 2 out and have in parentheses everything else. So this will be 3y squared plus 16y plus 5. Now, because of the way that distribution works, if we were to multiply that 2 back times each of these terms, that would give us 6y squared, 32y, and 10, right? So that would bring us right back to what we had started with. So that's how we know that this is true, that this line is equal to this line, and that's why we're allowed to do that. We're allowed to take out the 2 and put it out front. So any common factors, that's what you're going to want to do first. You have to factor out that those common factors. All right, so now what we're going to do is we're going to check for any special cases like difference or sum of squares. Now this particular one has a 3y squared and it has a 5. Neither of those is a perfect square. So if it was, for example, a 4, that's a perfect square, but 3 is not. So it's not going to allow us to use any special cases for this problem. So we could do factor by grouping. Usually that's something that you'll see when there's 4 terms, but in this case there's only 3 terms. And so factor by grouping is one way, and we could turn this into a factor by grouping problem, and I'll talk about that in a little bit. But the way I'd like to approach this is a little bit different. So first what I'm going to do is I am going to break 3 up into its factors. So that's, for example, 3 and 1. And I'm going to do the same thing with 5. What are the factors of 5? We have 5 and 1, right? So what I'm going to do is I'm going to multiply the 3 times the 1 and the 1 times the 5. So 3 times 1 gives me 3. 1 times 5 gives me 5. Now, in order for this to factor properly, those would have to add up to 16, but they only add up to 8. So that is not the pair that I'm looking for. So I'm going to keep looking. This is 3 and 1, and instead of excuse me, instead of 1 and 5, see, we don't really have a whole lot of options here. Because 5 is prime and 3 is prime. So we're going to just flip this around and we're going to try it as 1 and 5. And I'm going to draw my lines here and do the multiplication on this. So 3 times 5 gives me 15, and 1 times 1 gives me 1. And when I add those together, that does give me 16. So I've actually found the right combination in order to make this factor properly. And so what I do to finish this out is I just put parentheses around that. and I put my variable in. This is a y. So what multiplies out to be y squared? Well, that would be a y times another y. So each of those binomials is going to get its own y. Now, what about the signs? What I'm going to do is I'm going to look at this sign. So because this last sign is a plus, that tells me that they are going to be the same sign. So they're either both positive or they're both negative. If it's a plus, that means they're the same sign. If it's a negative, that means they're opposite signs. So in this case, they're both going to be positive because this middle term is a positive. So the only way that's going to happen is if this one right here is a positive, in other words, that product is a positive, and that product is a positive. That's the only way that we're going to end up with a positive 16. So we have to put in pluses for both of those. So our answer, let's not forget that we have a 2 out front here. Our answer is going to be 2 times 3y plus 1 times 1y, or I can just write it as y. I don't really want to write the 1. It's just sort of an understood that's there, plus 5. All right, so that is our answer. Now we could check it just to make sure, just to be absolutely confident in our answer. We should always check these things because why not? You know, especially if you have the time, go back and check all your answers with these factoring problems to make sure you got it right. So we'll start with 3y times y. That gives us 3y squared. 3y times 5 gives us 15y. 1 times y gives us a y. And 1 times 5 gives us 5. That way, every combination of each term in the first binomial got multiplied times every combination of terms in the second binomial. Now we still have our 2 out front here, and the middle terms can combine together. So 15 plus, and then there's an understood 1 here. We don't put it, but it's understood to be a 1 here. And so those would add together to give us 16. So we have 16y plus 5. I'm just carrying those other terms down. And the 2 is now going to multiply times each of those. And what does that give us? That gives us 6y squared, which is what we wanted to have, 6y squared, plus 32y, which is what we wanted to have, 32y, plus 10. So it's been factored properly, and we've checked our answer to make sure that it worked. So I'm going to do some more factoring problems. Make sure to click to one of the other videos and check out some other situations, because we haven't gone over special cases yet, but I will show you that. And I'll also show you how to deal with factoring by cubes, so stay tuned. Like and subscribe if you haven't done it already.